Hi friends, welcome back. This is Santosh Kumar. Today also we'll continue with the Bode plot. In the last class we started the Bode plot. We have seen the Bode plot is nothing but the frequency analysis tool, and in that we draw always the magnitude and phase spectrums or the graph between frequency and magnitude or frequency and phase. Okay, this is kind of non-linear scale we are using over here, that is the log omega semi-log. Okay, the frequency component we are taking on the log scale, and magnitude and phase component we are taking on the linear scale. Correct? We have seen the relation between decade and octave. 20 dB per decade equal to 6 dB per octave. The procedure we have seen in the last class for the very first the open loop transfer function we have taken, that is the GSHS equal to K. And one more thing, this is always the Bode plot I'm talking about. This is also the approach for the open loop transfer function. So for the open loop transfer function, now we'll see the Bode plot, Nyquist plot, polar plot, and any other, and the root locus we have seen already. Correct? Only one is for the characteristic equation, that is for the closed loop control system, and that is the RH criteria. And one more thing, friends, before going to start, let me tell you that thing. Soon we'll cover the control system. Don't worry about that. I'm getting so many mails. People are asking when I'll complete the control system, when I complete the control system. Friends, actually, the time when I started the control system, I never thought that I'll be continuing with you people. But I tried my best, and I think near about daily you are getting one video. Correct? So from that time I'm continuously preparing the video lecture. So what I want is, I want some time. I can't say you the perfect and proper timing, but please try to understand. This is the 11th of October today, 20 or 25 maybe. I want my quality should be maintained. So whenever we'll watch this video, it will be helpful for you, and whenever you'll go in the GATE examination, you'll attempt the question and you will remember me. Yes, So the point is, soon we'll cover it. Chinta na karo, bahut jaldi karenge. Don't worry. Okay, let me start. So the last class, see, where is the point? Wait a minute. In the last class, we draw the Bode plot for the GSHS. There is the constant quantity K. Okay. Here. So according to the approach or the procedure to find out the Bode plot, first we'll find out the magnitude. Magnitude is the K, and the phase of this constant quantity is the 0. So we have drawn over here the magnitude spectrum and the phase spectrum, or the magnitude graph and phase graph. So entire this thing we discussed today, we can come with one conclusion with this point, that the magnitude spectrum or the graph of magnitude is depend on K values, the constant value whatever we have over here, but the phase value or the phase graph or spectrum is not depend on K values. Okay, so today's lecture I'll start with this conclusion point or note point. Please note down this. The phase plot is independent of the K values, whereas magnitude plot depends on K values. Okay, so in the magnitude plot we always give the shifting of 20 log K. Whatever and whenever we'll draw the Bode plot, always we'll shift that by 20K. Later we'll discuss about this. Don't worry. So today we'll see, the last time we have seen for the constant K term. Today we'll see n number of poles at origin and n number of zeros at origin. Okay. So let me start now. N poles at origin, n zeros at origin. So the open loop transfer function will be poles we need at origin and n number of poles, so s to the power n. Okay, and if we'll talk about the zeros at origin, it will be s to the power n. Okay, the next point in the procedure is we have to convert this into the pure frequency form, that is the put a is equal to j omega. It will be j omega to the power n, isn't it? Later we'll solve this one, the zeros one. First we'll see this. Okay, so find out the magnitude. The magnitude simply gj omega hj omega mod. The magnitude of this term you know very well, and you know how to solve this. This is n. So what you are getting is omega to the power n. This is your magnitude. Now the very next point is you have to convert this magnitude in dB. Why we are converting this in dB? Because you know we plot the magnitude spectrum in the dB only. Okay, that's why we need the dB value, that is dB. How to find? 20 log this one. So this n will go up, this entire thing I can write over here 20 log omega to the power minus n. According to the log property, this minus n can come forward. 20n log omega you will get in your hand remain, isn't it? So this is your you know magnitude, which is purely depending on the value of n and the value of omega. So this is minus 20n log omega. This is the relation between magnitude and number of poles at origin, isn't it? So this part is not over completely. We'll see the you know the phase plot also, phase calculation also. Wait a minute. So this is magnitude we calculated. I need the slope of this magnitude also. Whenever we'll draw the plot of magnitude, we need the slope of that line also. If this is your magnitude plot I'm drawing, at what angle it will move. So I need the slope of this also. So what you will do, the slope is with respect to this, that is log omega over here. In this line always log omega. Over here you have magnitude in dB. Okay, now this is one plot, that is the magnitude plot. In the phase plot you will be having the phase, and over here again you will have log omega. Okay, so you will differentiate this with respect to log omega. What you are getting is you are getting minus 20n. Okay, and this is in dB per decade. Why decade? Because we have chosen the log scale over here, that is 10 log. Means the log scale is itself is the, what I mean is the next frequency will be 10 times of last frequency. This is nothing but the log scale. Okay, so 20n dB per decade. This is the slope. And if you'll find out the phase you have to find out. Before that you need the transfer function, that is j omega h j omega. It was 1 by j omega to the power n, isn't it? You have to find out the phase of this. Okay, find out the phase. Directly I'm writing over here. So this upper phase, this is 0, phase provided by the numerator 0. What about the denominator? N times it's coming, and it's j omega n. This is nothing but the pi by 2, if you remember. Should I do it again for you? A plus jb is nothing but tan inverse b by a. Over here you have only j omega, isn't it? So it will be tan inverse omega. The real part is 0, so this will become infinity, and tan inverse infinity you know that is pi by 2. So n times this are coming in the you know multiplication of the terms. We can add the angles. So this is kind of j omega j omega j omega up to n times. So this angle provided by this is pi by 2 pi by 2 pi by 2 up to n. So these are in multiplication, we can add. So this is 0 n pi by 2. Now This is clear to you people. Now these two terms are in division, so we can subtract this 0 minus n pi by 2. So your phase you are getting over here is minus n pi by 2, isn't it? So this is your phase. So let me clear some part over here, then we'll discuss about this. So the phase phi, can I take this phi or the angle of GH j omega, and it is nothing but minus n pi by 2. Okay, and your magnitude in dB you got there, that is minus 20 n log omega. Okay, the slope of this dm by d log omega you got minus 20 n, where what this n denotes, this is the number of poles at origin, isn't it? So what is the conclusion over here? See, whenever you have the number of poles at origin, n number of poles, suppose, or let me take for example, I'm taking over here, you have 3 poles at origin. This is one condition to you. Okay, it means the magnitude because of this will be definitely minus 60 dB. Okay, the slope because of this, the slope will be minus 60 dB per decade, isn't it? And if you'll talk about the phase will be 3 times of pi by 2. This is the condition you have. Again on the phrase page I'll talk about this. If you have n number of poles at origin, magnitude will be here n equal to, let's take 3. So magnitude will be minus 60 dB provided by these 3 poles at origin. The slope will be minus 60 dB per decade, and the phase provided by these 3 is nothing but 3 into pi by 2, isn't it? This is all about this. Now let me come to the 0 part also, then we'll compare the output. Over here the 0, now directly I'm writing over here for this. The magnitude in this case will be omega to the power n. Magnitude in dB will be, this will be n20 log omega. Everything will be plus now. In this case everything was in minus, here it will be plus. So when you will find out the slope of this, it will be 20 n into 20 dB per decade. Okay, here slope was, okay, it is there. Okay, here the slope is minus 20 n, here the slope is 20 n dB per decade. Okay, here the phase is minus n pi by 2, and here phase will be in plus. Okay friends, so now we will compare these two things. Come here, this is the comparison between n number of poles at origin and number of zeros at origin. If you find out the magnitude plot for the pole cases, you will get the magnitude in dB minus 20 n log omega. In the case of 0 you will get 20 n log omega. The slope over here you will get minus 20 and this and that. Everything is same. Over here you are getting in negative terms, you are getting over here in positive terms. Okay, everything. If this is minus, here plus, minus, plus, plus, minus, minus, plus. Okay, so the point is now I have to draw the point, or the scene is I have to draw the phase plot and the magnitude plot. Okay, as you people know, the graph of Bode plot is like this. On the x-axis, I'll take frequencies. This is the log omega scale, okay? Here I'll take mdB, magnitude in dB. And in the phase plot also, we always draw the two plots in the Bode plot. Number one is magnitude plot and the second is phase plot. Okay, so the point is, for the poles, the magnitude will be minus 20 n log omega. It's starting from 0.1, okay? The starting frequency is 0.1. Okay, then 1 and like this it will go. Okay, it's not 0 exactly because 0 is not defined. Log 0 is not defined. So the starting frequency is 0.1. Okay. So the point is, now I have to draw it. Okay. So when you will draw this, first I'll take this one, pole at origin. My magnitude I have to draw magnitude in dB. So this is minus 20 n log omega, means log, the starting frequency is 0.1, log 0.1 is minus 1, so this will become 20 n, this will become plus. It means at the origin I can say my magnitude I'm getting is 20 n. Okay, now as this will, this omega will increase, the frequency will increase, it will decrease. Okay, it will decrease continuously like this graph I'm drawing. You can find out these individual values on the different values of omega. It will definitely at 0 dB when the omega equal to 1. At omega equal to 1, it will be 0 dB. You can put over here magnitude in dB at omega equal to 1. So it is minus 20 n log 1. This is 0. So 0 dB, correct? 0 dB. So the magnitude spectrum will cross the x-axis. This is 0 dB when omega equal to 1, and it will go like this up to infinity if we are not getting any corner frequency. The corner frequency in the upcoming slide will talk about that, don't worry. So this is all about the magnitude plot. If I'll talk about the phase plot, this is minus n pi by 2. Minus n pi by 2 means if this is your 0, so this is n pi by 2, it will go like this, fixed n pi by 2. Like this it will go continuously because it is not depending on frequency. Directly you will get n pi by 2. N is the number of poles at origin. If 3, then minus 270 degree you will get throughout. Okay, friends, I can come by this information to this note point. Whenever the transfer function consists by pole and zeros at origin, then the magnitude plot starts at the rate frequency of 0.1 as we discussed, with the magnitude of opposite sign. And why I'm taking opposite sign actually, because here in the magnitude we are getting 20 n, but at the starting it is going to start plus 20 n. So directly this is the point for remembering, that will take the opposite sign of the magnitude. It should be passed through 0 dB line at intersection of the omega equal to 1 and extend up to infinity if the corner frequency does not exist. This is the scene in the both cases. Okay friends, so don't worry about this. Now see to the 0 term. Okay, let me erase something over here, then we'll see this 0 part. Now for 0 we'll check. Okay, this is at 0.1, log 0.1 is minus 1, magnitude will become minus 20 n. This is minus 20 n, so it will go like this. If you'll draw this, it will increasing function at omega equal to 1 exactly, it will cross to the 0 dB line. It will go like this up to infinity if you are not getting any corner frequency. Okay, so this is the magnitude graph. If you will plot the phase graph, it's plus n pi by 2. N is the number, pi by 2 is like this. It's take n pi by 2. If n is 1, you will get 90 degree. If n is 2, you will get kitna hoga bhai? it's a 180 degree. Okay, if n is 3, you will get 270 degree. Like this it will go. Okay, is it okay to you? Now the point is, if n equal to 3, it will start from minus 60 dB line, isn't it? Like this. I hope this point is clear to you. Now the conclusion part is 0 always contributes, 0 always gives positive slope, that is the rising slope, means we'll get like this. Okay, and the pole will always gives negative slope, always you will get like this. Okay, it will be minus 20 dB per decade, or 40 dB or 60 dB or whatever. It's depend on the value of n. Over here it's 20 dB per decade, 40 dB, 60, 80. Okay, like this. Now the next we will see this question. Draw the Bode plot for the open loop transfer function 100 divided by s to the power 8. Okay, so j omega is nothing but 100 j omega to the power 8. Can I write like this? Now let's find out the magnitude directly. So magnitude will be, this is 100 omega to the power 8, isn't it? And let's find out this in dB. So as you know, our formula was minus 20 n log omega, so it will be minus 160 log omega, isn't it? This one is dB. If you'll talk about the slope you'll get minus 20 n, that is minus 160 dB per decade. What about phase? The phase will be minus 160. Am I right? No. This is 8 into pi by 2. Is it clear to you? Now let's draw the graph. So the magnitude is minus 60. So it will start as we discussed in the note point at 160 dB. This is in dB. Okay, and this line will go continuously crossing at omega equal to 1 to the 0 dB line, and will continue till infinity, isn't it? So this is my line. Let me make it clear for you. So like this it is. Okay, and what about the phase plot? The phase is 8 into pi by 2, so this is like this. This is the minus, and the value is minus 720. Okay, so this is not our complete graph. Remember in the first class or in the first lecture I told you, for the Bode plot, always you will shift the graph by 20 log k. This is by default you have to do for any graph. Okay, in the different book the approach is different, but my approach is whatever graph I'll draw, after drawing all this, applying all these methods, I'll shift the magnitude by 20 log k. That will be the actual Bode plot. So here it will be 20 log k value is 100, so this is nothing but 40. So I'll shift this graph to 40 dB at every point. Let me change the color. So this will become 200 dB actually, and this will be like this, like this. So this is the actual graph. Actual Bode plot is like this. Okay friends, if you people have doubt in this, I'll clear this doubt into the next class. Okay, so friend, this is all about this class. Marini updates kosam Gatematic ni subscribe cheskondi. మీ సబ్జెక్ట్ డౌట్స్ ని క్లియర్ చేసుకోవాలంటే ఫేస్బుక్ లో మమ్మల్ని ఫాలో అవ్వండి. ఓకే, యూ కెన్ సబ్స్క్రైబ్ LGA for new updates. You can subscribe Gatematic for the new updates. You can find us on the Facebook for the doubt solving. We'll meet in the next lecture. Till then, take care and bye.